So some of you might be familiar with the KISS principle. Keep it simple, stupid is what that stands for. More scientifically, we can call it the principle of parsimony. If you want to get even more scientifically, philosophically opaque, you could use Occam's Razor. The basic idea is when doing research, you want to include as few variables as you possibly can that will allow you to answer your question. Here's a researcher who got stuck in the trap that a lot of us get into, which is they've got all this data and they don't know what to do with it. They didn't have a plan when they collected the data, and they thought, well, I'll figure it out once we're done. A lot of times we're so excited to get our study underway that we don't do good experimental design, and then we end up with data that we don't know how to process. We've got a bunch of extra information. Now, having said that, I'm talking about experiments right now. There's a long tradition in other techniques, descriptive techniques in particular, when you're collecting survey data, or when you're administering surveys plus some psychomotor scales and other kinds of things where it's all paper and pencil. There's a long tradition of collecting a ton of data and then using it for years to write papers about, mining that data for different possible relationships and things like that. That's not what I'm talking about right now. I'm talking about experiments. So if you're conducting an experiment where you're going to have control over the variables, you want to include as few variables as you can while still answering the question, which takes us back to my little chart that I drew us, right? I feel like this is all we need to get started. At the max, I really feel like this would be adequate. I think my research partner makes a good case that you could have a confound. If you just use the frame rate as the only independent variable, you could have a confound where you may end up with misleading data if some of your participants are experts and some are novices and you haven't identified them as such. So I think he makes a valid point on that. I don't think we need to necessarily go into what type of expert they are right now. But that's me. I want to keep it simple, stupid. I want to keep it as straightforward as possible. I want to include as few variables as we possibly can, because I don't want to end up with this. Now this is actually, it looks worse than it really is because they're reporting all sorts of stuff here. So they've got the results of experiment 4 in their study, and they've got search performance, recognition performance. They had a 4-way analysis of variance, which means that they had some between subjects variables, some within subjects variables. A 4-way ANOVA means that there were 4 independent variables. Over here they've got that same 4-way ANOVA, but now they had different dependent variables. They've got just a bunch of, here's another 4-way interaction. They've got a lot of things going on here in this study. You don't want to be in this condition where first thing out of the gate, the first experiment you ever conduct produces a graph like this. You want to have as simple and as straightforward, and what I was taught when I was a grad student was the phrase is elegant. That way it doesn't sound simple, it doesn't sound rudimentary, it sounds like you did it on purpose, right? You're just kind of trying to keep it simple and elegant. Yeah, that sounds good. Okay, so let's talk a little bit more about variables. The nature of variables. So as I already mentioned, a variable is an event or a behavior that can assume at least 2 values. So the part I said earlier was the 2 values part. So an event or a behavior that can assume at least 2 values. Okay, now a lot of the times when we are collecting data, the variables of interest are really more concepts than actual concrete things. Like, for example, maybe I want to find out whether experiencing personal attacks, that's my independent variable. Some participants will have a confederate in the lab room who says insulting things to them, and other participants won't have that happen. So maybe I'm interested in whether experiencing personal attacks lowers a person's self-esteem. Okay, self-esteem is going to be our dependent variable here. What's self-esteem? That's a concept. That's not something that like is concrete and that we could measure in some kind of objective way. We've got to come up with some way of measuring that concept. And so, for example, I might operationally define self-esteem as your score on a self-esteem scale, on the Rosenberg self-esteem scale, or something like that. What's intelligence? Maybe I want to measure intelligence. What is it? It's a concept. So I'm going to have to operationally define what I mean by that concept. So I might say that it's your score on an IQ test. Now, we could all sit here and debate whether your score on an IQ test actually represents your intelligence, which is exactly my point. We don't know for sure what intelligence is, do we? It's a concept. So we need to come up with some kind of operational definition for the purposes of our experiment so that anybody who's reading our experiment knows what we mean by the term intelligence. Same thing with depression. A lot of times people use the word depression as if it's a thing. It's a set of symptoms. And you only have to have 5 symptoms that last 2 weeks or more, and the 5 symptoms come from this array of 5 categories. Each of those 5 categories has at least 5 possible personifications of those symptoms. There's no such thing as just depression. There's a cluster of symptoms that would be defined as depression. So how am I going to operationally define depression? I could say your score on a Beck Depression Inventory. I could say I'm going to bring in a clinician who's going to assess people for depression, and that's how I'm going to decide if the participants are depressed or not. It doesn't matter what method I use. It's that I delineate that I used a method to define these concepts that I'm going to be measuring. So that's what we call an operational definition. We're going to define the variables as a function of the operations that it's going to take to produce the evidence that that concept was present. All right. So many things in psychology are conceptual that it's really necessary to use operational definitions. All right, let's talk about independent variables. For shorthand, we use the IV as shorthand, and I know when I was a student in research methods and then for a while in stats, anytime they'd write IV on the board, I'd think, why are they suddenly putting a Roman numeral 4 up there? So I just thought I'd go ahead and in the title right here say, IVs are independent variables. They are not Roman numeral 4s in research methods classes, at least, or in stats classes. The independent variable is the variable that the experimenter purposely manipulates. Okay, so I'm narrowing myself down in this definition to only those independent variables that can be manipulated by the researcher. Things like your level of expertise with video games would not fall under this definition, would it? That's a different kind of experiment, and we're going to talk about that in another chapter. The whole reason for doing the research that we're doing is to find out whether the independent variable has an effect on the dependent variable. That's the whole reason why we're doing the study. It's like, why are we even collecting data? To find out whether being in this condition or that condition produces a different outcome. So what can serve as an independent variable? I could give you a reward for correct answers and see if that affects the correctness of your answers. Or I could do like Milgram. You guys have all had an intro to psych. I sure hope your teachers taught you the Milgram study, where people were supposedly the teacher was shocking supposedly the learner for incorrect answers. That'd be an example of giving punishment, as some people got punished, some people got rewarded, kind of thing. Being allowed to have rest periods, being administered drugs. There's a classic study on anxiety where some participants were given caffeine pills and told that they were placebos, and some people were given caffeine pills and told that they were caffeine, and then they were asked whether they felt anxious or not later, and those who got caffeine pills said, no, I don't feel anxious, I'm just jumpy because I took caffeine. And the ones who got what they thought were placebo pills said, well, yeah, I'm feeling very anxious. That's a great example of a drug test that psychologists might use. the type of instructions we give you, the task we assign you. These are all examples of independent variables. This is by no means a comprehensive list of independent variables. These are just examples of things that we as the researchers could have control over and then see whether it has an effect on the dependent variable. The whole purpose for doing the research is to see whether these variables, whatever it is that we've decided for our experiment, have an impact on the dependent variable. Okay, so let's go ahead and take a little, let me go through this little chart and then we'll take a break. Okay, so physiological independent variables are going to be ones where we manipulate the physiological state of the participant. So for example, I gave you a caffeine pill and told you it was caffeine, or I gave you a caffeine pill and told you it was a placebo. See whether you experience that as stressful. Experience independent variables would include any kind of situation where we're going to be manipulating something about your experience, how much training you got, how much time you were given to learn something, what kinds of instructions you were given. Those are all examples of experience independent variables. And then situational variables would be anything having to do with the environment that you're in. Is it warm? Is it cold? Is the lighting adequate or inadequate? Is there noise? Is it a warm, cozy lab, or is it a cold, sterile lab? I mean, these kinds of things are what we call situational independent variables. Again, this is not a completely comprehensive list of things that could serve as independent variables, but this cluster is pretty good. Physiological, changing something about the state of the learner. Experience, something about the things that we've said to you or done to you or trained you with or whatever. And the situational, things that are going on around you that you aren't even necessarily made aware are part of the experiment. Okay, now let's go ahead and take a little break and we'll come back and talk about the two-group design.